Buildings are huge users of energy, materials, water. Where we put them determines how much we need to travel around. And of course, buildings are also a slow turnover capital stock. So once you build a building the wrong way, it will continue to gobble resources for decades.
Traditionally, buildings have been created by an architect with an idea, who then gives that three-dimensional idea to a mechanical engineer, a structural engineer, a landscape architect, etc. And they say, here's the building now, heat it, cool it, put a structure around it, etc.
Generally, we conventionally design how a building looks and then figure out how to make it work, mechanically, electrically, sustainably, etc. This process sort of turns that inside out.
Integrative design means designing the building as a whole system and optimizing it for multiple benefits rather than optimizing components of the building or subsystems in the building for single benefits.
I can summarize integrative design in 4 words, and they all start with E. It's everyone engaging everything early.
The way we learned back in 2000, and we were lucky enough to have some very, very good mentors, was to do it in a way that may cost you a few extra dollars up front in the planning process, but saves a tremendous amount of money as you build the building.
What we found is that high-performance buildings aren't about adding a green covering at the tail end. That's always expensive, and that's what gives building owners and other folks in the building community the impression that green buildings are expensive.
What we try to do is look at all of these systems, how they fit together, and then see what elements are redundant and what can be eliminated.
We may spend more on insulation and windows, be able to make a smaller heating system, and then operate it at much lower costs over time. So that's the concept we call tunneling through the cost barrier.
We're so conditioned to thinking that very efficient must cost more, but through integrative design, you can tunnel through the cost barrier. At first, the cost goes up as you save more and more energy. It goes up more and more steeply. That's called diminishing returns. But if you keep going, you often get to the point where you can eliminate mechanicals, for example, and then the cost comes down more than you paid to get there. And why should you get there the long way around when you can tunnel through the cost barrier directly to that destination?
One of my favorite Einstein quotes is the definition of insanity, right? It's doing the same thing over and over, but expecting different results. So if we expect buildings to perform significantly better, we need to change the process by which you put them together.
In a collaborative design process, you need to and you want to understand each other's disciplines.
One is we know that we need breakout space for this one.
Collaborative design is a lot more fun.
The integrative process asks us to understand that maybe rather than either or, we can achieve both and. That's when you know you're really on an integrative path.
When the whole team works on the whole building as an integrative design problem, you pay less and you get much better results. Everything gets better. There is no compromise, no trade-off.